right, so today we are finding all roots, which are zeros. We're finding all the roots. We are also writing these in factored form. We did this already before we took our quiz last week. We did it, but when we did it before, I gave you some of the roots. Now I'm giving you none of the roots. So you have to come up with all of them on your own. So it's the new thing. In the first paragraph, it talks about finding values of P and Q, and you should have done this in Algebra 2, where you're finding all the possible rational roots. So rational means not irrational. Rational means it can be written as a fraction. That's why it has the first 5 letters of ratio. That's where I was talking about earlier, putting, like dividing two numbers, putting a number over a number. Okay? So a ratio is when you divide two numbers, when you compare two numbers by division. So this P over Q thing that we're about to do only gives you possible rational roots. If we have irrational roots, this will not give it to you. Okay? Yes.
Like, why would you want the irrational roots?
Well, we're going to find all the roots so that we could graph one of these babies by hand.
Oh.
Right? So we need all of the roots. The rational roots we're going to find a lot easier than we can find an irrational root. Irrational would be a number that is a decimal that goes on forever and it does not repeat. Does anybody know a number that goes on forever, a decimal that goes on forever and does not repeat?
Pi.
Other than pi.
Negative pi.
Other than anything with pi. Stop saying pi.
1.39.
No, not if we divide it by 9, it's a repeating decimal. So I want something that does not repeat. Maddie knows what it is. Square root that isn't like a perfect square. Square root of a non-perfect square, those are irrational numbers. So if it's a square root of a non-perfect square, it's irrational. Other than that, and pi. Other than that, it's going to be rational for what we're doing. All right, so what we're going to do is we're going to find all the possible rational roots, and we're going to make a list of them. To find them, you first have to factor the last term, which is the constant term. You have to factor that. How do we factor 5? 1 and 5, right? 42. We're going to factor 42. I'm just going to write those numbers. By the way, either write really small, or use extra paper, or use the back. Because I didn't give you enough space. I didn't know that until later. But. Okay, so 42, how do we factor 42? 1, 2, what goes into 42? 3, what goes into 42?
21.
Yeah, I'm going to do small in order. 6, 7, 3 times 14, 2 times 21, and 1 times 42. Right? That's just factoring. Then what we're going to do is we're going to put all the possible combinations of plus minus P over Q. That's it right here. All the possible combinations of plus minus P over Q. So I did hear some people say, oh, I remember doing this last year. You should have done it last year. So you're doing plus minus because 2 negatives could make a positive 5. So we could be positives or we could be negatives with these. So we're putting plus minus for every single one. And I'm always doing P over Q. So I'm going to start here and I'm going to do my P's over my Q's. I'm going to use 1 first. I'm going to do plus minus 1 over 1. I'm going to do plus minus 1 over 2. Plus minus 1 over 3, plus minus 1 over 6, plus minus 1 over 7, plus minus 1 over 14, plus minus 1 over 21, plus minus 1 over 42. Yes?
Did you do like a notation, like,
No.
to, like, so you don't after plus minus each one?
Are you complaining about?
I was like, I really thought that was.
This is how you will always see it written. Okay, then we're going to do the 5 over each of these numbers. Plus minus 5 over 1 is just 5. Plus minus 5 over 2. Plus minus 5 over 3. Plus minus 5 over 6. 5 over 7. Oops. 5 over 14, plus minus 5 over 21, plus minus 5 over 42. All right, that was the hardest part of today. Woo!
Or are we going to do that again?
Not for that question.
Oh, yeah.
Yeah. Okay. So what we just did is we found all possible rational roots. How do you know if the very first one, positive 1, really is a root? Or how do you know if negative 1 is a root? Or how do you know if 1/2 is a root? Or how do you know if negative 1/2 is a root? How do you know if it's a root is the same thing like a 0 or an x-intercept? How do you know? What do you think? Well, all of them work with the 5 and the 42. Every single one of them does. How do we know that it actually works in this? So what I'm trying to do is I'm trying to get this into factored form, and I'm trying to list all my roots, which are listing all my zeros, which we did last week. Remember, we had to list all those and we had to write them in factored form. I'm trying to do that. So how do we know, like, our very first example, it could be x equals positive 1, which would be the factor x minus 1.
Oh, you gotta plug it in.
What do you mean by plug it in?
Could be X.
I guess you could do it that way, but, yeah, oh, yeah. So what we would have to do, if we were doing this by hand, which the honors classes do it by hand, and you might have to do this by hand in a future course, you would use like synthetic division to see if 1 is a factor. How would I know it is a factor when I did synthetic division? What would happen at the end? It would be a 0. So if I got something other than 0, then I'd have to try a different value. I'd try negative 1. See, that's a pain. But this is what you're going to have to do if you are doing it by hand. So if you're not bringing a calculator to class, you're going to do it by hand. On a quiz or a test, if you don't have a calculator, you're doing it by hand.
So we can use a calculator.
Yeah. So for what I'm requiring you to do is just tell me the possible ones. We won't check them all by hand. You just do the bare minimum and write them down on your paper. Okay? So now, can you go ahead and graph this equation on your calculator, and we'll see how we can actually find the zeros.
Is that like the benefits of checking them by hand, like why the honors class?
Is there a benefit?
Yeah, because it's really like efficient.
Yes, but unless you understand how, like somebody had to create this. They had to know how it worked to create it. So if you don't know how to create it, you're not really getting mathematically.
Press graph or whatever.
Yeah, graph it.
And then what?
And then we'll talk together about it. I gotta graph mine too. Okay, there was one thing I forgot to mention. How many maximum roots could we have? Maximum zeros. How'd you get 3? It is the degree. That's going to tell us the max amount. So when I hit ground, and it looks like I have 3, that means, all right, I should be able to find 3 of them. I could find less sometimes. You'll see one that has less than that degree. But this one, there's 3. So we're going to go ahead and find a 0. I'm going to hit second trace. I'm going to choose 0. And we're going to go, let's see, -2, 0, -1. And we find a 0, and it should say, yep, there is a 0 at -1. Did you try that further? Are you guys working ahead? Did you find another one? Are you working ahead or not?
Yeah.
Okay. I don't know if I should pause here and show you what to do with the -1, or Looks like you guys are trying to find another 0. What happens when you try to find another 0? Were you able to get this 0? It's like 0.142857114. So, well, here's the thing. You don't know if it's irrational every single time by looking at it. This could be irrational because I see no pattern. Maybe a pattern, but I don't see enough numbers to know if something's repeating. So I don't know. So sometimes it will be irrational. So I'm going to stop with the calculator for a moment. I'm going to go back to the notes. We know that -1 was a 0. We knew that for sure. We knew x equals -1 is a 0, is a root. So we're going to change that. We're going to put it in factored form, x plus 1. Right? That's what we did last week. Then I'm going to factor it out of the polynomial that we have. I'm going to factor it out and see what I have left over. Just like we did last week. Remember how we did synthetic division? We factored stuff out. Can I use synthetic division? Yes, I can use it for this one because it starts with an x and it's to the first power. So yay, we're going to use -1 and then our coefficients 2, 1, 6, and 5. Do synthetic division quickly. And if you get a remainder of 0, yes, we really did find one of those zeros. We found one of the roots. We just have to find the rest of them. How many are left? We found one of them. How many are left?
2.
Okay, if there are 2 left, that means this is quadratic. And I have 2 choices. I can factor it, or if I cannot figure out the factors, or if it doesn't factor, what is my backup plan? Quadratic formula would be my backup plan. So once you have it to a quadratic, you can use factoring or a quadratic formula to solve. And look at this. Does it factor? Should we spend 10 minutes figuring out if it should factor, if it's not obvious?
No.
Or should we just do quadratic formula? Because it works every time. It's totally up to you. But if it doesn't factor, you're going to have to use quadratic formula anyway. So we do opposite of b plus or minus square root of b squared minus 4 times a times c all over 2a. This will be on a calculator part. So you can plug that into your calculator if those are big numbers. You will have a calculator for these times because you will need to look at the graph and figure out zeros. So you will be able to use quadratic formula with the calculator. So I plug it in and I get 41 plus or minus 29 over 84. If it square roots perfectly, that tells me I could have factored it. But I didn't, and I'm already this far, so I might as well just solve it. But if it does square root, I could have factored it. So my 2 answers, we got 41 plus 29 over 84. And 41 minus 29 over 84. What's the first answer? I don't want a decimal. I want a fraction. 5 over 6, yeah. And how about 41 minus 24 over 84? Minus 21 over 84. To make it 13. What?
I got 4 times 6.
I don't think that's right.
I got 1.
1/7, it should be. You type something in wrong? 41 minus 29.
Oh, I divided by 8.
So those should be the numbers. So now we need to write those as factors. We went over this last week also. How do we write x equals 5 over 6 as a factor? Say it again. How'd you get that 6x?
So it's like, you have to make it equal to 0.
Right, but how'd you get the 6x?
Multiply by 6.
Right, we're gonna multiply by 6 first, and then you'll make it equal to 0 for that. So we have 6x, and then subtract the 5. So this one here, I've got x equals 1 over 7, so we're gonna multiply by 7 first. It's 7x minus 1 as my factor. So we have our zeros. Negative 1, positive 1, 7, and positive 5, 6. In our factored form, f of x equals x plus 1, 6x minus 5, and 7x minus 1. Now, how do we know we did it right? Because last week I remember people using synthetic division when you weren't supposed to. You were supposed to be using long division, and then like you multiply back out and then equal. How would you know you did it right? Yeah, you could check those first coefficients. If I multiply 1x times 6x times 7x, am I getting 42x to the third? Right? It could be one thing. Do my last terms give me 5? 1 times negative 5 times negative 1. Those work. Another thing that you could do to check it would be, you've already graphed it, right? You've already graphed it. It's already in your calculator. If you choose like y2 and you type this one in, let's do that. You've already graphed it. Choose y2 and type your answer in, and hit graph to see that they're the exact same equation.
Yeah.
Okay, now go to the table.
We're typing the same question in y equals.
As your y2. You already have the first one there. So if you typed them both in, and some of you, especially with the ones that have the non-color, the older ones that aren't colored, if you go to the table, it's a lot easier to tell than just looking at the graph. Because you look at your table, like all the values should match. Is something extra in there? You know, something extra in there, or is that the one you just put? So if you go to your table, if you have them both typed in, who's got them both typed in?
I do.
Okay, I was saying, let me use one that's not dark. I appreciate the offer though. If you go to your table and we're looking and you're looking at all the y values, they should totally match side by side. You have them both typed in if you've done it right. So that can be a good check for you. Yes. Okay. I can. Okay, so once you have that, we're going to do the next one, the P over Q. So you want to start the P over Q part.
Oh, God.
I think it's 6. It's 6. I don't know why. Because there's something weird happening, and I gotta remember how to say it. You do, but you have something weird happening. Other students have had this happen. I just remember how to
No.
Could you do your P's over your Q's?
Number B, or letter B.
Letter B.
It's the coefficient of 1. So it's plus or minus 1. Right?
No, it's P over Q. So what are your P?
1 over 1.
P's are the last one.
Oh, I didn't know that.
1, 3, or 9.
Oh.
And then your Q's are the first one, just 1. So for this one, plus minus P over Q is just plus minus 1 over 1, plus minus 3 over 1, or plus minus 9 over 1. All right. So those are all the possible rational solutions. Those are not all the possible roots. Those are just the rational ones. So how are we going to find at least one of them? Well, you could do synthetic division 6 times to figure it out, or type it in your calculator. Let's look at the picture to give us a head start. You are going to have to do some division eventually, but at least get us a head start by plugging in your calculator. So you look at the graph. How many zeros maximum could we have for this? 4. The degree is 4. And you look at your graph, and we see the end behavior is up, up. So we see all of the graph here. But how many zeros are there?
3.
Right, Jordan. Say that again, Jordan.
One of them has a multiplicity of 2.
Right. There was a reason why we learned that last week or so. One of them has a multiplicity of 2 that tells you there's actually 2 zeros here, and then 1 and 1. So we have a total of 4. So you might have questions in your assignment that have multiplicity. You'll be able to recognize that. Where do you think that 0 is? How do you know it's at -3? No, you use your calculator. You could use your table too. That's fine. Really is that negative? Because you have like a weird.
It's just like, I mean, it's 3.
Yeah, there's a slight inaccuracy with the calculation. I don't have to fix that. I have no idea. It's always been there. Even back in the day, when I had my first graphing calculator when I was a freshman in high school, that was a very long time ago. I had the 82. It still did it then too. Yeah, so it's something that I guess is just going to be there. All right, so what did we just have? We had x equals -3. So that factor is x plus 3. So can I use synthetic division?
What is that little thing you got going there?
An arrow? So we're going to do -3 for synthetic division.
Why did we choose 3 again?
Sorry, I can't calculate and talk.
Okay, well, why did we choose 3 again?
Because we looked at our picture.
Yeah, but isn't there more zeros that we could choose from?
Yes, but that one is a nice easy answer. And when you look at the others, I can tell they're going to be decimals.
Are they all, are we always trying to find the easiest answer?
Don't you like to find the easiest answer?
I know, but there's always going to be an easy answer to it.
No. Example C. So, example B, yeah. But you just have to like go with what you have. All right, so I took out -3. Then I look, and if I took out 1x, I'm now down to x to the 3rd. But at x to the 3rd, you can't really factor or use quadratic formula. So I need to get it down to x to the 2nd. We are going to use the second -3. Because there were 2 of them. So we're going to factor out a second x plus 3. Remember, there's going to be 2 of these. Yeah, so we're going to do a second one to make this down to squared, so then we can do things with it. So now, if what's left over factors, you could probably get the rest of the factors from the graph also. Did anybody try finding the other zeros? Anybody try that yet? I mean, they're decimals. And on example A, we had decimals and it ended up being like 1/7 and 3/8, or 8/3. If you try to factor this one, I think this is a very easy one to try to factor. When you multiply together, give you 1. How's that going to add up to give 5?
It's not.
Okay. So what does that tell me about?
Quadratic formula.
That tells me this will not factor. That tells me I'm going to have irrational solutions for my other 2. There's going to be square roots in my answer. So we will be using quadratic formula for sure on some of these. use my quadratic formula, and I got to -5 plus or minus square root 21 over 2. So my zeros are my roots. They're called roots on this homework assignment, but it's all the same stuff. My roots, we've got -3, and then we've got the -5 plus or minus square root 21 over 2. So right there I have 3 roots. There's really 4 because there's multiplicity. So I'm not going to write -3 twice. And we have to write it in factored form. This one's g of x, right? G of x, this one's g of x. So we'll have x plus 3, but since there's multiplicity of 2, we have to square it for factored form. Now here's the part that might be a teeny bit confusing. Just a itty bitty. Writing this part. So I have x equals this. Okay. What I'm going to do is I'm going to make it equal to 0. So I'm going to think about this as being like one whole number. It is a whole number. It's some sort of decimal that's irrational, goes on forever, doesn't equal. So how would I make that equal to 0 if this is one whole thing?
So you're not going to multiply by 2.
Not. And I'll show you why when we're done. No, I'm going to make it say equal 0. I'm going to subtract that. I'm going to subtract it. So I'm going to have x minus that. Okay, but there's really 2 of them there. There's 2 answers there. One's plus and one's minus square root 21. So one of these is going to be x minus -5 plus square root 21 over 2. The other one is going to be x minus -5 minus square root of 21 all over 2. And I'm going to answer, I think it was Michael's question about multiplying by 2 or not multiplying by 2. Because on the other one, we multiplied by, whatever was underneath. If I were to multiply all this back together, what would my first term be? Or what would it need to be if I were multiplying this all back together? My first term was an x to the 4th, 1x to the 4th. So if I multiply all that back together by not multiplying by 2, that's how I'm getting just the 1x to the 4th. So it just depends on what's like the first term. You just have to kind of like figure it out and check your answer. All right, let's do the lesson. Okay, so what are we going to start with?
P's and Q's.
Now, if you need space, you need space. If you need space, you will need space. You could just use the back, and I have the numbers up there if you just want to use the back for your P's and Q's. That's a good place to put it. Because 120. Now, let me just do my 12 first. What's my value? My factors of 12. Factors of 12. 1, 2, 3, 4, 6, 12. Okay. My factors of 120. 1. What also gives them a 120? 2, 3, 4, 5, 6, 8, 10, 12. Okay, once I hit 10 times 12, I know I'm just going backwards from here. So what makes 8? 15. What makes 6? 20. 5 is 24. 4 is 30. 3 is 40. 2 is 60. And 1 is 120. No? Mm-mm.
I was praying.
Mm-hmm. Sure you were. Okay. So what I'm doing is I'm taking every single one of those, plus minus of every single one of those, and I'm putting it over every single one of these. So I already did all of them over 1. I just crossed that one off. I just used that one. So now what do I have to do? Okay, but, when I put them all over 2, you gotta be careful. What happens when I put them all over 2? Don't work too far ahead of me. Somewhat.
Simplify.
Some simplify. So let's just do the first one. We're gonna put this one over 2, so plus minus 1/2. Then we go to do the second one. We do plus minus 2 over 2. But that's 1, and we already have 1 up there. I'm not gonna write it twice. Plus minus 3 over 2, we don't have that one up yet. Plus minus 4 over 2, I already have that one up. Plus minus 5 over 2, don't have that one yet. Plus minus 6 over 2, have that one. 8 over 2, yep. 10 over 2, yep, got that one. 12 over 2, yes. 15 over 2, nope, that one's new. 20 over 2, don't need that one. 24 over 2, 30 over 2, 40 over 2, 60 over, oh, is that it? Okay. So I'm done with all the 2s.
Incredible.
I know, it is fabulous, isn't it? Now we're going to do the 3s. We're going to do plus minus. We're going to do, so we already did the 2s. Now we're going to do the 3s. We're going to do 1 over 3 plus minus 2 over 3. I don't have to do 3 over 3. I do need 4 over 3.
Outside what we're doing.
What?
What are we doing? I'm so serious. We're doing.
I'll answer the question in a moment. I'm just listing all the possible zeros, rational zeros. But then we're going to use our calculator to actually find. So all we have to do is list the ones that could occur.
So why didn't you do 4 over 2?
Because 4 over 2 is equal to what number?
2.
And then I've already written it up there. So you don't need to write the same number twice.
Okay.
Yeah.
A 5 over 3, I believe there's not a minus sign.
There should be.
Oh, okay. I was making
Uh-huh. You go back to 3.
sure.
Where was I? 10, 12 over 3 is fine, 15 over 3, 20 over 3. 24 over 3, 30 over 3, 40 over 3. 60 over 3, 120 over 3. Okay, do we understand this process?
Nope.
Oh, so we should keep going.
Nope.
Do we understand this process?
Yep.
None of the ones that I gave you in the homework are this big. Okay? But basically, I'm sorry. I'm so sorry. Basically, we're not going to spend our class time just listing these because all I want you to know is that you can't repeat them and how to find them. Okay. So what would we do next? We would do plus or minus what?
60. No.
No. We have to start doing 1 over
We would start again with 1 and go to 4. Then 2/4, but we already have that one. Then 3/4. And then 4/4, but we already have that one. And then 5/4. So we do everything over 4. And then we do everything over 6. And then we do everything over 12. But I'm not going to take our class time to do that. Let's just finish this question. What's next? We have all of our possibilities. Now you go back to the front. Type it in your calculator, yeah. You can finish the rest of it on the front. I just knew that the P over Q wasn't going to fit. That's it.
I made it fit.
Oh, okay. You could write small and make it fit. We also didn't finish it though. So I need a root. Does your graph look like my graph when you got it graphed?
Yeah, but I think
To identify roots in your table, it's changed in the y, like positive, negative.
Yep. So if you're looking at your table, I know that there's going to be one from 1 to 2. I know there's going to be one between 1 and 2. I know there's going to be one between -3 and -2. But to actually find them, second trace 0. I'm going to choose the left one first. So I'm going to go negative what? Negative 3, negative 1, negative 2-ish. And it tells me that we do have a 0 at negative 2.5. Is that number rational? Meaning it can be written as a fraction. What fraction is that? What fraction is it?
I can't find my little black square that helps me like settle that down.
Yeah, mine was, I couldn't remember that.
It tells you at the bottom where it is, but you just type in a number. Doesn't matter where the
Wait, I'm kind of confused how you do 3. You did negative 3 and negative 1. Then why do you do a negative 2 like in your calculator?
I'm like,
Because at that point it says for me like guess or whatever. But that's
Oh, I think so big and then negative 1 and negative 3.
Oh.
I just think
Okay.
any in between.
can't get it from
Okay.
Any numbers in between. You know?
I think so. Why didn't it show up?
Because
It's off, yeah, it's like off the window. It's somewhere there, and it tells you at the bottom where it's located, but.
Yeah.
Okay. All right, so I know that x equals negative 5 halves is one of my roots. That would be what as a factor? Arrow. Give me 2x plus 5. Can I use synthetic division? Should I use synthetic division when it is 2x? No.
Long division.
Let's do long division. So I told you I'm giving you an example that has everything that you could see in today's assignment. So this one you might have to use long division in today's assignment.
Is that the hardest part?
What'd you say?
Like, is that the hardest part of this?
The hardest part? Is that what you said?
Yeah.
I think the hardest part is just figuring out what to use where. P's and Q's are not the hardest part. They're just annoying. Okay, so we're going to divide, and we're going to get 6x squared, and then we distribute 12x to the third plus 30x squared. We draw the line, change the signs, add them. Negative 50x squared. Bring down negative 77x. Do the whole thing again. Divide 2x into negative 50x squared, so minus 25x. Distribute. Negative 50x squared minus 125x. Draw the line, change the signs. 48x. Bring down. Plus 120. Divide 2x into 48x. 24. Distribute 48x plus 120. Draw the line, change the sign, 0. Okay, so 2x plus 5 is one of our factors. What is left over? We have 6x squared minus 25x plus 24 left over. So what are our choices now?
Now factor.
We are left with a quadratic, so we can maybe factor it if it factors, or if it doesn't factor, quadratic formula. This one, you would know if it factors if you found any other factors that are rational numbers. So if you want to know if it factors, go like second trace, hit 0, choose a different one. 0 to 1.5. So I found that another one of my factors is at 1.5.
Rational.
So it is rational, so I can factor it. What is that factor anyway? It's going to be 2x minus 3. That's what x equals 3 over 2 is going to equal, 2x minus 3. So what's the other factor? You like FOIL it back together, 2x times 3x is going to give me 6x squared. Negative 3 times what is going to give me positive 24? And if I FOIL the outside and inside, it should give me negative 25. So that's negative 16, right? Negative 9, yes, negative 25. So I factored it correctly. So we have our zeros. What was the first one? Negative 5/2. I forgot. And then 3/2. And then what is this last one? 8/3. And then our factored form, this one was h of x equals, and we have 2x plus 5, and then those two. 2x minus 3, 3x minus 3. Okay, so I'm going to hand this out, and you should not be cleaned up. Let's start question 1 on the worksheet.